carrying the first of two Voyager spacecraft to extend man's senses farther into the solar system than ever before.
As a species that has yet to venture beyond our planet's orbit, humans possess a reasonably solid understanding of the universe. Our knowledge of the universe's functions, however, is predominantly theoretical and based on assumptions. This is why space probes like Voyager 1 play a vital role in expanding our understanding of the cosmos. By transmitting real-time data, these probes provide information about the outer reaches of our solar system, areas that we may not be able to explore ourselves for many decades. But what happens when a space probe that has been a dependable source of valuable data for decades begins transmitting unusual signals and unsettling information? Recently, the NASA chief made a startling announcement, leaving scientists bewildered by the series of alarming signals received from Voyager 1. The question arises, what do these peculiar signals signify, and how do they impact the future of Voyager's space exploration? To unravel these mysteries and gain further insight, join us as we delve into the unsettling signal anomaly of Voyager. The Voyager space probes, launched in the 70s, were designed to explore the outer planets using knowledge from previous missions like Pioneer 10. Voyager 1, built with advanced technology, included a powerful communication system and a digital tape recorder to handle the challenges of deep space. It also had instruments for stabilization and realignment, crucial for navigating unpredictable regions. To sustain power on its long journey, Voyager 1 was equipped with radioisotope thermoelectric generators, RTGs, instead of solar panels. These generators used plutonium-238 to produce electrical energy. Despite the reduction in power over time, Voyager 1 provided invaluable insights into our solar system's planets. Upon its launch from Earth in September 1977, Voyager embarked on a journey that took it past Mars and towards its primary destination, Jupiter. After reaching the giant planet on March 5, 1979, Voyager commenced a detailed exploration of the Jovian system, investigating its magnetic fields, moons, rings, and hyperactive radiation belt. By coming as close as approximately 217,000 miles from Jupiter's core, the probe captured unprecedentedly detailed images. After successfully completing its comprehensive examination of Jupiter and its moons, Voyager 1 utilized the planet's gravity for a gravitational assist, accelerating its velocity. This slingshot maneuver propelled Voyager 1 towards its next destination, Saturn, which it reached in November 1980, becoming the first spacecraft to perform a flyby of the ringed planet. Coming within 124,000 kilometers of Saturn's surface, the probe's cameras captured detailed imagery of the intricate structures of its rings and the dynamic state of its atmosphere. Concluding its investigations, Voyager 1 commenced its journey to the outer reaches of the solar system, employing Saturn's gravity for one final gravitational assist to enhance its speed. As the probe ventured closer to the solar system's edge, it experienced a gradual decline in energy, as predicted by scientists. Consequently, non-essential components were deactivated to conserve power for the mission's remaining objectives. By February 1998, Voyager 1 had reached an impressive milestone distance of 69 astronomical units, equivalent to approximately 6.4 billion miles from the Sun. This feat had only been previously achieved by one other spacecraft, Pioneer 10. Continuing its onward trajectory, Voyager 1 ventured into interstellar space, despite no longer possessing its imaging system to transmit visual data of the solar system. However, it still retained vital instruments like the plasma wave subsystem, which played a crucial role in studying particle behavior, particularly as the probe approached the termination shock. In February 2004, after several years of uneventful data and signals, scientists received telemetry indicating that solar winds from the Sun had decelerated to subsonic speeds. This revelation indicated Voyager 1's entry into the termination shock, a boundary where solar winds interacted and collided with the interstellar medium, resulting in a significant reduction in speed. Voyager 1 detected this interaction through substantial compression and distortion of the surrounding magnetic field. While the termination shock had been a theoretical concept, Voyager's measurements provided concrete evidence and established its definitive location. It was estimated to lie between 11 to 13 billion kilometers from the Sun. Voyager 1 crossed this boundary in late 2004, venturing into an unexplored region of the outer solar system where solar winds not only decelerated to subsonic speeds, but also equaled the external pressure from interstellar cosmic radiation. This marked the beginning of the heliosheath, an area where solar winds could no longer overcome the inflow of cosmic radiation. At a distance of approximately 10.8 billion miles from the Sun, Voyager 1 observed the solar winds reducing to zero due to their deflection by the interstellar winds. This significant milestone was confirmed by NASA mission controllers on December 13, 2010, as Voyager 1 transmitted signals containing data collected by its cosmic ray system. Although this system had been on board since the probe's inception, its relevance had been limited within the solar system. However, within the heliosheath, Voyager 1 detected increasing levels of cosmic radiation, enabling scientists to study their acceleration, origin, and history. Due to Voyager 1's departure from solar wind observation range, NASA instructed the spacecraft to change its orientation in order to measure sideways solar wind motion. This maneuver, performed in March 2011, involved a practice roll to test the spacecraft's reorientation capabilities. While its course remained unchanged, Voyager 1 tilted its axis 70 degrees clockwise relative to Earth to detect the lateral movement of solar winds. This was the first maneuver conducted on the spacecraft in about 20 years following the 1990 family portrait. After successfully completing the observation, Voyager 1 realigned itself using Alpha Centauri as a guide star and resumed transmission to Earth. In 2011, NASA announced that Voyager 1 had detected Lyman alpha radiation originating from the outer regions of the Milky Way galaxy, marking the first such detection within our galaxy due to the heliosphere's protective shield. At this stage of Voyager 1's journey, NASA disclosed the probe's encounter with a region of outer space known as cosmic purgatory. In this area, solar particles were nearly absent, while the solar system's magnetic field doubled in strength as a response to external cosmic radiation pressure. Within this realm, high-energy electrons from outside the solar system and the galaxy had increased over 100 times compared to their initial observations within the solar system. This region was located approximately 113 astronomical units from the Sun, signifying Voyager 1's departure from the solar system's edge and entry into interstellar space. In June 2012, NASA announced Voyager 1's detection of significant environmental changes, including an increased number of charged particles and cosmic rays, marking the inner boundary of the heliosphere. This milestone established Voyager 1 as the first spacecraft to transition into interstellar space at a distance of 121 astronomical units from the Sun. At this juncture, Voyager 1 benefited from not relying on solar energy as its power source, since sunlight took over 16 hours to reach the spacecraft. Traveling at a speed of over 10 miles per second relative to the Sun, Voyager 1 would require approximately 17,565 years to traverse a distance of 1 light-year. In terms of proximity, reaching the closest star to the Sun, Proxima Centauri, which is about 4.2 light-years away, would take Voyager 1 over 73,000 years. However, Voyager 1 was not heading towards Proxima Centauri, but rather charting a course straight toward the constellation of Aquarius. In 2012, NASA mission controllers reported Voyager 1's detection of intense collisions with high-energy particles, believed to be cosmic rays originating from supernovas far beyond our solar system. This surge in high-energy particles coincided with a sharp decline in low-energy particles emitted by the Sun. Scientists at Johns Hopkins University declared that Voyager 1 had exited the heliosphere and entered interstellar space. However, they noticed an unexpected difference in the magnetic properties of the region. Dr. Ed Stone, the Voyager project scientist at the California Institute of Technology, revealed the discovery of a previously unknown region within the heliosphere, with a connected magnetic field allowing particles to pass through. This surprising find indicated that the region's magnetic field was 10 times stronger than anticipated, It was considered the final obstacle before Voyager 1 would fully exit the solar system and enter interstellar space. Since 2012, Voyager 1 has been in interstellar space, and scientists have eagerly monitored its signals. And recently, NASA chief announced that during one observation cycle, Voyager 1 began transmitting perplexing and alarming data. The data originating from Voyager 1's Altitude Articulation and Control System, AACS, presented impossible scenarios that seemed unlikely in interstellar space. NASA's Jet Propulsion Laboratory officials were unable to determine the cause of this unnerving signal and erroneous data. Despite the puzzling signals, Voyager 1 continued to function properly, collecting and transmitting data to mission control on Earth. Nevertheless, the received data was essentially unusable at this stage of the mission. Currently 14.5 billion miles away from Earth, communication between Voyager 1 and NASA's mission control experiences substantial delays. Signals require over 22 hours to travel from the probe to Earth and vice versa. After extensively investigating the perplexing signals sent by Voyager 1, mission control at NASA finally uncovered the underlying cause. They determined that Voyager 1's AACS, which ensures the probe's antenna remains directed toward Earth, had encountered an issue. It was discovered that the system was transmitting information through a deactivated and corrupted computer, leading to data corruption during the delay. As a result, Voyager 1 unintentionally transmitted junk telemetry data back to Earth. NASA swiftly resolved the problem by issuing a new command to Voyager 1, instructing the probe to cease sending data to the corrupted computer and resume using its functioning counterpart. This fix was implemented promptly, and Voyager 1 has resumed transmitting accurate data regarding its observations of interstellar space. Nevertheless, scientists remain perplexed as to why Voyager 1 began using the corrupted computer without any command to do so. The scientific community speculates that Voyager 1 may have encountered cosmic radiation containing charged particles, causing system commands to be distorted and resulting in the switch to the corrupted computer. However, NASA has not provided an official explanation for the system malfunction. While Mission Control believes this incident to be isolated, there is widespread speculation about the possibility of a similar occurrence in the future due to the unknown nature of interstellar space. What are your views on this? Tell us in the comments below.